Okay, so 4-6 is mainly about identifying things called domain and range, and then identifying whether or not something it does represent a function or not. Okay, so the domain, just so everyone is aware, is the inputs or the x values of a function, and they're all the possible ones. The range is the outputs or the y values of a function. So there are different things that we're going to do. A lot of the stuff we work with is functions, unless they're actually given to you, in ordered pairs. So let me just show you. So the first problem says, identify the domain and range of each relation. So a relation is like a set of ordered pairs. It's saying -2 maps to 0.5, if you were to put that on the graph, right? Represent the relation, the set of ordered pairs, with a mapping diagram. Is the relation a function? Okay, a mapping diagram is basically where you write out your domain numbers and your range, and then you use arrows to map numbers. Let me show you. So what you do to make a mapping diagram is you list out your domain and your range. Usually it's vertically like this. So my domain is all my x values. So -2 is in my domain. 0 is in my domain. 4 and 5. Those are all the x values. Then you list your y values on the other side, but if there are repeats, you don't list them more than once, okay? So this first one is a very straightforward one that, they start you with the easiest thing. So my first number in my range is 0.5. My second one is 2.5, then 6.5. Then we have another 2.5, but we do not write it again in the range column because it's already represented. Then what you do to make a mapping diagram is you draw arrows from each domain value to their range value. So it says -2 goes with 0.5. So you make an arrow like this. Boop. It says 0 goes with 2.5. 4 goes with 6.5, and then 5 also goes with 2.5. So this is a mapping diagram, or sometimes they call it an arrow diagram because there's arrows. And what they do to say whether this is yes a function or it is not a function is you look at the domain side only right here once you've done it. And if there is exactly one arrow coming out of each number in the domain, you say this is a function. If there was any of them on this side that had more than one arrow coming out of it, it would be no, it is not a function. Okay? The range side can be, you can have as many coming out of that range side out of one as you want. They could all go to the same one. But the domain side can only have one exact arrow coming out of each one. What they say is that each input has one output, is what you say. All right, let's try it again. So a lot of times when we do these shorthand, we just use a D for the domain and an R for the range. That's fine. And we list them out. Who can list me the domain this time? Carla, go ahead. 6, 4, 5. And notice there's a repeated 6, but she did not say it twice. Good job. Okay. Who can tell me the range for this function? David, go ahead.
5, 3, 4, 8.
Perfect. Okay, and now we will do the arrows. So 6 maps to 5, and they use those words too. They say they maps. 6 maps to 5, 4 maps to 3, 6 maps to 4, and 5 maps to 8. Okay, which side did I say we check for domain? Okay, so If I check my domain side, is this a function, yes or no?
No.
This is not a function. What value, and function you can abbreviate fxn, what value makes it not a function? 6. 6 maps to both 5 and 4. Okay, so that's the first thing, is using, first of all, knowing domain and range, right? And using mapping diagrams. So a lot of times on NWEA, they will give you the arrow diagram like this, and they will ask you, is this a function or not a function? It's pretty easy once you know how to do it, okay? And so that's a good, easy question to get correct. Okay, here's another one. This time, though, it says, is the relation a function? Use the vertical line test. Okay, so the vertical line test, sometimes abbreviated VLT, and I wrote the actual definition down, so I want to make sure that I give you the exact definition here. Okay, it says any vertical line may not pass through a graph more than once to be a function. Okay, and so what they want, if they're asking you to determine whether it's a function or not using the vertical line test, your job is to graph it or to look at a graph if they've already got one for you. And you're dropping these vertical lines down the graph in your mind. And you're seeing, like, if you have a vertical line and it hits in more than one spot on the graph, then it's a no. All right, so let me show you. So this one, it's easy to graph this. The highest number I have to go up to is 4, right? Because -4 is the furthest from 0 we get here. So let's make ourselves a graph. Oh, sorry. Thank you. And so we'll go 1, 2, 3, 4. We'll make a 4 by 4 graph here. For this one, you don't necessarily have to list the domain and the range. We're just going to graph it and use the vertical line test. So we graph each point. -4, 2. So left 4 up 2. -3, 1. 0, -2. -4, -1. And 1, 2. So you put the dots on there. Now, a lot of times on these tests, like the SAT or the NWEA, they will literally just give you the graph or give you the ordered pairs like this, and they'll say, using the vertical line test, determine whether this is a function. So in your mind, you've got to place vertical lines through every single one of these spots and see if it hits in more than one. So if I do a vertical line right here through this dot, it only hits one dot. If I do one here, it only hits one dot. If I do one here, it only hits one dot. But if I do one out here, it hits 2, right? So that makes this not a function. If it hits 2 spots, it is not a function. And we say because it fails the vertical line test. If it hits more than once, it fails. Okay, now the next one is really kind of where we're going with this and where you want to use your graphing calculator, okay? And so on this one, right, you can either make a table by hand and then graph the points on there by hand. Or you can go in your graphing calculator, go to y equals, if you have something in there, clear it out, and then type in the function. So -x squared plus 3. Type that in. And then press graph, because we're looking at graph for vertical line test, right? And so this gives me a pretty good picture of this graph. And so I'm going to draw it in on my paper. And this one, you just have to make sure that you get like, where it kind of crosses. So it looks like it crosses the y-axis at what number? At 3, yeah. And our x-axis, it looks like it crosses somewhere between 1 and 2, but closer to 2, right? So if I draw my graph on here, it kind of looks like, and I usually just put little marks where it's got to hit, and then I just kind of sketch it in. Okay, now remember that this is moving outward further and further out as we go. It would keep on going, right? And so the question is, does this pass the vertical line test? So if I start dropping vertical lines on here, right? And so if I drop a vertical line, let's say here, it only hits the graph in one spot, right? If I drop a vertical line here, it doesn't matter. It only hits in one spot. Is there any place on this graph that it would ever hit more than once? So this, we say, is a function because it passes the vertical line test. Okay, so 2 ways we can determine functions. We can determine functions by using the domain and range and seeing if there's any domain numbers that map to more than one range number. Or we can use vertical line tests, okay? So that's kind of like the main point. And now, of course, they're going to put it where we have story problems and things like that, okay? So let's go. Problem 3 says that the function w of x equals 250 times x represents the number of words w of x you can read in x minutes. How many words can you read in 8 minutes? So this is evaluating a function. So this right here is called function format. We're used to it looking like this, right? Y equals 250x, right? So in function format, that's this. W of x is saying in this function words, we can get 250 words in x minutes, right? And so how you write it is like this. It says, how many words can you read in 8 minutes? So what they'll write it is they'll say, okay, w of 8, the function of 8, is equal to 250 times 8. And you can do that in your head or using your calculator. What is 250 times 8? 2, what is it? 2,000? Okay. So we say, how many words can you read? W of 8 equals 2,000 words. What that's saying in shorthand is that if you read 250 words per minute and you read for 8 minutes, you read 2,000 words. It's literally, is it the same or different than using this format that we've used the whole time? It's the same. It's written differently. So it confuses kids when they don't learn how to read different formats, right? This is just written in a different format. So you can get that correct now. All right. I stapled my packet in the wrong order, so I apologize. Hopefully you stapled yours in the right order. Or I might have stapled these together. I can't remember. Did I staple them? Okay, so find the page that says 4-6 continued. I should have stapled it right in order, but sorry. Whoopsie daisy. Sorry. Okay, now here's the next part. And there's kind of a lot to this lesson, so we may end up doing more than one day on this lesson. That's okay, because NWEA is going to creep in there for us, all right? But, okay, And we'll make that judgment call as we go. All right, here's another one. The domain of, now we know this is just function format. The function of x, which is just like y equals negative 1.5 times x plus 4 is 1, 2, 3, and 4. Okay, domain means which values? The word domain. X values. So this right here is our domain. This is our x values. What is the range means they're asking us what are the y values if we put in these x values. Okay, so what we do is we say, all right, the function of 1, that's the first x value, is equal to negative 1.5 times, not x now, times what? 1 plus 4. And we get the answer. What's negative 1.5 times 1? Negative 1.5 plus 4. So the function of 1 equals negative 2.5. That should be the first answer in our answer choices. So which one is out already? A. It's not A. It's not A because they don't have a negative 2.5 in choice A, right? Okay, so now we find the function of 2 because that's next in there. Equals negative 1.5 times what? Plus. Okay, so we got to figure that out. Negative 1.5 times 2. Negative 3 plus 4. Okay, so the function of 2 is positive 1. That's got to be our next answer in the range.
D.
Okay, so why is this one got a negative 0.5 in there? They've got a negative 0.5 in there, though. So our next one, you said negative 1.5 times 2 is negative 3, right? Plus 1 is 1. But this one's got our 2.5 and our 1 in there. Why does it have a negative 0.5 in there? That's going to be one of the other ones. Okay? So, what? Nope, it's got to be D, right? Because C doesn't have a positive 1 in it. Does B have a positive 1 in it? No, it doesn't have. And the problem with A is that it doesn't have a negative 2.5, right? And so we can check the rest of them, but we don't have to. Makes sense? Okay, let's go. Last but not least, everyone's favorite. Okay, now this is literally identifying a reasonable domain and range. It's not that hard, but we overthink this, okay? Because we are overthinkers when we are algebra students. All right, you have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 feet squared. The function A of Q equals 100 times Q represents the area in square feet that Q quarts of paint can cover. What domain and range are reasonable for this function? What is the graph of the function? Okay, so remember our domain is our x values and our range is going to be our y values. Okay, so in this case, x is A or Q, really? Our x is A or Q? Q. So our domain is our Q or quarts, right? Our range is our A or our area, right? So think about this logically. Quarts of paint. Can you have negative quarts of paint? No. So we know that there's not going to be any negative numbers. Can you have half quarts of paint? You can have half quarts of paint, can't you? All right, let's graph it a second and look. So keeping that in our head, go to y equals. We're going to graph this. Now, it doesn't say A of Q. That's okay. We're going to put 100. 100 x. We're just changing it back to this because that's what it says. And then we're going to press graph. and nothing shows. Why not? Our window, right, is not going to be good. So, but that still should show something. It's way too small. Let's change our window to negative 100 to positive 100 on both and see what happens.
I'm confused.
Oh, I don't know. I'm not sure why mine's not showing on this calculator.
It's like on the side. Far right.
Oh, I'm not sure. Hold on. I'm going to try something real quick. I'm not sure why this calculator is not. I'm just using a random one here. Okay, so this is what should show eventually. Let's see what window I've got. Okay. Right? So now let's think about this. We said that in this case, we can't have negative quarts of paint, right? So really, we should make that 0. We can have 0 quarts of paint. Up to 100, are we really going to have 100 quarts of paint? Probably not 100. I mean, how many quarts of paint, maybe maximum, to paint your trim in your house? Okay, let's go with 10. All right. Are you going to have negative square footage that you paint? No. So make that 0. Are you going to paint 10,000 square feet in your? Probably not. Okay, you might paint maybe 5,000. Well, it depends how big your house is, but probably not even that. But let's go ahead and now graph it. Okay. So let's talk about our domain now. That's our x values. So we can't have negative values, but we can have decimal values, right, of paint, can't we? So our domain here, we would say our domain would be all real numbers greater than what? Greater than 0. Greater than or equal to 0, actually. Could you write that as this? Q, is greater than or equal to 0. Yes. Which way is shorter and nicer? A lot of times they use that, but sometimes they'll use words. Now, our range is the area that we can paint, right? We can't do negatives there either. Can you paint partial areas, like decimals? So is our range really the same thing? All real numbers? Yeah, same, right? All real numbers greater than or equal to 0, right? Could you write that as an inequality too? You could say your A of Q, or your area, is greater than or equal to 0. So domain and range, like in the beginning I showed you, they gave you specific numbers on the front, right? The very first one, that had to be domain, had to be range. But in the real world, it's usually a range of numbers. Okay, that's it for the lesson. Kind of a long lesson today. Let's look at our assignment.